In this lecture, we will be talking about Diophantine equation, Maths Olympiad Number Theory problem we will be solving. It involves congruences, modular arithmetic, Diophantine equations and integer optimization. Here, we will be solving an equation 7a congruent to 23b mod 37, 17b congruent to 19 mod 3a. You see here 3a. And what is the value of a plus b if a plus b is less than 999? And I am from Maths and Science by IITian channel, and in the website I will be posting a blog or article on this particular video. You can read it. That's my website is maths&science.com. Please visit it. Now let us try to solve. It involves many concepts. Please pay attention to each and every concept. It is a concept based problem and it's a lengthy problem. Please pay attention. Please be patient to understand it fully. It has many concepts detailed in this particular example. Linear congruences, modular inverse, congruence transformation, divisibility, integer parametrization, elimination of variables, bounding arguments, and optimization under divisibility constraints, Diophantine equations, and inequalities. These are all the things which are conceptually discussed in this particular problem. Please pay attention to it. Please see till the end so that you will understand everything, and this type of problems, if they come in the examination, you will be able to do it very easily without any problem. Now, it's a lengthy problem. Please pay attention to it. I will be explaining step by step everything. What is the question given here? Question is, two congruence equations are given to us. 7a congruent to 23b mod 37 and 17b congruent to 19 mod 3a. You pay attention to this one, 3a. We have to solve for a plus b is equal to how much? If a plus b is less than 999. The maximum value of a plus b we have to find out when a plus b is less than 999. Now, let us try to solve it. Let us take the first congruence. Equation, that is 7a is congruent to 23b mod 37. If you see, all the values here are primes. 7 is a prime, 23 is a prime, 37 is a prime. And we have to find out a. How to find out a? Here, 7a is equal to 23b mod 37. Let us little bit think over and let us see. 7 into 16 is equal to how much? It is 112. That is mod 1, that is congruent to 1 mod 37. Because when you multiply 7 with 16, we will get 112. When you take out 101 from it, it will be 111 is equal to, we are doing modulo 37, mod 37. Hence, we have to check for 37. 111 is equal to 37 into 3. Hence, 112 congruent to 1 mod 37. Did you get this? Why we have taken 112? Because we have to find out A. To find out A, we have to find out 7 inverse. Because here 7A is there, not direct A. Inverse modulo we have to find out. You are able to understand this step? No. I have explained about the inverse modulo in my previous lectures. A lot of lectures are there on number theory in the same channel. Please see them if you have any doubts. And if you have any doubts, please write in the comments column. I will reply. Seven A is congruent to 23B mod 37. At the same time, 7 into 16 is congruent to 1 mod 37. What you will understand from these two? This one particular one implies 7 inverse congruent to 16 mod 37. From this we can write like this. Because we require 7 inverse, we have gone into this process. From the above 3 equations, A congruent to 23B mod 37 implies A congruent to 23 into 16B, because 7A here, because 7 inverse is congruent to 16 mod 37. This is what we have got from here. Inverse modulo. This is one equation, 7A 23B mod 37, and 7 inverse is congruent to 16 mod 37. By combining these two, we will get A congruent to 2316B mod 37. This is a very important step. Please try to understand. When 7 goes on the right side, what happens? 7 inverse. That 7 inverse is congruent to 16 mod 37. Mod 37, it will remain same. I am telling in the normal language. That 16 will be multiplied here. Whatever 16 is here, that 16 is taken here. Understood? This is how. This is one equation for A. A congruent to 23 into 16 is 368B mod 37. But 368 is equal to in terms of 37, 37 into 9 plus 5. That implies ultimately we have to find some A. A congruent to 368B mod 37 implies 368 is equal to 37 plus 37 into 9 plus 35. Now, let us concentrate on 368. 368 is equal to 37 into 9 plus 35 implies 368, that is equal to 23 into 60. That means 23 into 16 congruent to 35 congruent to minus 2 mod 37. What is 35? 35 is congruent to minus 2 mod 37. These are all things I have explained in my previous lectures. Hence, what we will get ultimately? A congruent to 23 into 16B mod 37 can be written as A congruent to 23 into 16. How we can write? Congruent to minus 2 mod 37. Here I can replace 23 into 16 by minus 2. These are all the basics from modular arithmetic. That implies A is congruent to minus 2B mod 37. That implies the first equation I will get in between of A and B as A plus 2B congruent to 0 mod 37. Let me say this is equation number 1. From which, if I write it in general form, it will be A plus 2B. Because I have told you it is a Diophantine equation. We are going to get the constants like this when it is going to be converted to Diophantine equation. This is the equation 1 instead of this. Did you understand? This is the first equation we have got. Now, what about the second equation? The second equation is 17B congruent to 19 mod 3A. That implies 17B minus 19 is divisible by 3A. Here mod some value is not given. Some variable is given in the form like 3A. That means 17B minus 19 is equal to 3A into some value n, some constant. Here A and B are positive integers and B cannot be 1. If it is 1, then 3an will be minus 2. If B is equal to 1, what happens? 17 into 1 minus 19 is equal to minus 2. It cannot be equal to 3an. because n is an integer, a is a integer, positive integer. Hence, b should be greater than or equal to 2. One more condition, inequality. Just see how we are developing the problem. Ultimately, what we are getting is that 17b minus 19 is equal to 3an with the condition that b is greater than or equal to 2. This let us say equation 2. We have got two equations. How many unknowns? 4 unknowns rather. Hence it is called as a Diophantine equation, and we have to break this Diophantine equation now. One equation is a plus 2b is equal to 37k, and second equation is 17b minus 19 is equal to 3an, and one condition is given that a plus b is less than 999. We have to find out the maximum value. By solving these two equations, I am not going into the step-by-step solution. These are all very simple, because then otherwise this lecture will be very long. We will get value of b as 111 kn plus 19 whole divided by 6n plus 17. Mathematics can be understood only by solving it. By doing mathematics, you treat it as a homework to solve and get this value b. Now, what we are to find out is a plus b. This is b. Then what is a plus b? A plus 2b is equal to 37k. That implies a plus b is equal to 37k minus b. That implies a plus b is equal to 37k minus b. What is b value? 111 kn plus 19. 111 kn plus 19 whole divided by 6n plus 17. That implies we have got the value of a plus b. Now we will get the value of a plus b now as a plus b. Solve this particular equation, we will get it in terms of n and k. A plus b is equal to 629k minus 19 whole divided by 6n plus 17. We know that n should be, b should be greater than or equal to 2. That is one condition we have. And there should be some upper limit for b also. That also we will be finding. Now we will go into the bounding principles. One is AB is greater than 0. and b is greater than or equal to 2 and a plus 2b is equal to 37k. From this, what is a plus 2b? Because a is greater than 0, a plus 2b should be less than 2 into a plus b plus a. That implies a plus 2b should be less than 2 into a plus b. That implies 37k should be less than 2 into a plus b should be less than 999. 2 into a plus b is nothing but 2 into 999. That implies 37k is less than 2 into 999. That means k should be less than 2 into 999 by 37. That implies k should be less than or equal to 53 when we talk in terms of the integers. Are you able to follow? At the same time, what is the value of a plus b we have got from this equation? I think here we have forgotten one term, 111 kn. That we will write here. 111 kn. Ultimately, what we have got here? A plus b is equal to 111 kn plus 629k minus 19 whole divided by 6n plus 17. K should be less than or equal to 53. That's what we have got here. With the condition K should be less than or equal to 53 and n should be greater than 1. That's what various conditions we have got in this problem. And b should be greater than or equal to 2. Now, let us try a value k is equal to 52. N is greater than 1. Now, by trial and error method, n is equal to 98 and k is equal to 52. We will get the maximum value and A is equal to 54 and B is equal to 935, which says A plus B is equal to 989. This trial and error for different values of k and n, why I have avoided is that the solution will be very lengthy. K already we know 52. Then apply this in this formula and try to find out the A plus B value and try to find out n also. N is greater than 1, B is greater than or equal to 2, K should be less than or equal to 53 and N is greater than 3. These constraints you apply and you will get an answer. K is equal to 52, N is equal to 98 and we will get an answer that A plus B is equal to 989. And you can verify this solution also from by applying different methods in algebra. And here what we have got is that we applied the principles of congruence, we applied the principles of Diophantine equation, and we applied the principles of integer optimization. That integer optimization, I request you people to work on it and do it as a homework, and solution I have given you, and try to see that how to do the optimization of integer to get maximum value. Integer optimization, I want to give it as a homework. And the maximum value what we have got for A plus B is equal to 989, which is less than 999, hence 989 is the correct value. With this I wanted to conclude this lecture. Best of luck to everybody. Thank you for viewing this lecture. If you feel there is a value addition because of this lecture to you, kindly share this lecture and my channel details to known people. Kindly hype this lecture and kindly subscribe to my channel Maths and Science by IITian. And regarding this optimization and other things, maybe in a couple of days or 2-3 days time, I will be uploading the full solution in my website maths&science.com, so that you will appreciate. Please visit the website also. It is a week back I have developed it, a week or 10 days back. I am uploading slowly one by one solutions in detail, and I will be discussing there also in the blogs. If you have any doubts, please comment on the comment column so that I will reply. Best of luck to everybody. Thank you for seeing my lecture. Thank you for listening to my lecture. Thank you.